Hello everyone, welcome back. Today I'll be covering the NCEA Level 3 Diff paper from 2024. This will be in 3 parts, with each part covering one question. So let's get started. With question 1a, we have to differentiate the function f of x equals the square root of 4 minus 9x to the 4. We can first rewrite our square root as a power of a half, and now we just apply our power rule. So go f dash of x equals, drop the half down, 4 minus 9x to the 4, negative half. But don't forget, we have an inner function too, so we're going to multiply through by negative 4 times 9x cubed. This is our chain rule. Simplifying that down, we get negative 18x cubed times 4 minus 9x to the 4 to the power of negative half. There you go. Part B. A curve is defined by the equation y equals x squared plus 3x plus 2 multiplied by sine x. Find the gradient of the tangent to this curve when x equals 0. So, find the gradient of the tangent, which implies dy by dx when x is 0. That's the value we're going to sub in. So, what's our function? What's our equation? It is x squared plus 3x plus 2 sine x. Now, we need to find dy by dx, so just going to write dy by dx equals, there's two separate functions of x, so we're going to use product rule. We differentiate the first function, multiply by the second function, and then we're going to differentiate the second function and multiply by the first function. At x equals 0, dy dx becomes 3 sine 0 plus cosine 0 times 2, because these cancel out, and that becomes 0. Sine 0 is 0, and cos 0 is 1, therefore we get 2 as our dy by dx, which is the gradient of the tangent. There you go. For part C, it states, for the function below, find the range of values of x for which the function is decreasing. So, at what values of x is the function decreasing? And the equation is this. So, we first have to find dy by dx, because whether it's decreasing or increasing, it'll be a slope. So we have y equals 3 times 2x minus 7 squared plus 60 ln x plus 12. So dy by dx equals, this is just power rule and chain rule. This becomes 6 times 2x minus 7 times the 2 from the inside function plus 60 on x, because ln x differentiates to 1 over x, and then 12 goes away. There's our dy dx, and it's decreasing, meaning our dy by dx is less than 0, right? It's negative. So we can set this to be less than 0, which becomes 12 2x minus 7 plus 60 over x is less than 0. We're going to expand that. 24x minus 84 plus 60 over x less than 0. We know x can't be 0 because it's in the denominator, so we'll multiply through by x. We get 24x squared minus 84x plus 60 is less than 0. We're going to divide everything by 12 as a common factor, so it becomes 2x squared minus 7x plus 5 is less than 0. Now it's just a quadratic. Form our quadratic equation. Must be 2x something x something less than 0. Now look at 5, it's only 1 and 5. So we'll get x minus 1 and x minus 5 here. That becomes 2x squared minus 2x minus 5x becomes minus 7x. Negative 5 times negative 1 becomes 5. And that's less than 0. So we have either so if you think about this parabola, it has a root at technically a root at x, so 5 by 2 is just 2.5 and 1. So we have a 1 here and 2.5 here, and it's positive, so it'll be like this. Right. So to solve this inequality, we're trying to find when is this parabola less than 0, and that's this part, which is between when x is between 1 and 2.5. So 1 less than x less than 2.5, and that is the range. That is the range of values of x for which the function is decreasing. There you go. That's part C done. Now let's look at part D. Find the x values of any stationary point on the graph of the function below and determine their nature. And the equation is right here. We're trying to find stationary points, meaning dy by dx equals 0. So our function is 2x minus 1 e to negative 2x. Now we can differentiate to find dy by dx. That is, we have two functions of x, so we're going to use product rule. We differentiate the first function, multiply by the second function, and we're going to add, differentiate the second function, which becomes negative 2 e to the negative 2x, multiplied by the first function, which is 2x minus 1. That becomes 2 e to the negative 2x minus 4x e to the negative 2x plus 2 e to the negative 2x. Simplifying that, we can pull out a common factor of e to the negative 2x. We get 2 minus 4x minus 2 plus 2, plus 2, which becomes 4 minus 4x times e to the negative 2x. Right, so that's our simplified derivative, dy by dx. We can now set this equal to 0 to find stationary points. So we'll have 4 minus, okay, we'll work up here. That becomes 4 minus 4x times e to the negative 2x equal to 0. So we have either 4 minus 4x equals 0, that becomes 4 equals 4x and x equals 1, or we can have e to the negative x equals 0. But if we take ln on both sides, we get negative 2x equals ln of 0. That's undefined. Natural log cannot take 0 or negatives, so that's undefined. So our only solution is x equals 1 as our stationary point. Now we're going to determine their nature. So we're trying to find the second derivative, d squared y by dx squared. So if dy by dx equals 4 minus 4x e to the negative 2x. So d squared y dx squared equals, this is again a product rule because of two functions of x. We'll get differentiate the first function, negative 4 e to the negative 2x. Add on the differentiate the second function, which is negative 2 e to the negative 2x. And we're gonna multiply on the first function. Right. Simplifying that, we get negative 4 e to the negative 2x minus 2 times 4 is 8, so it's minus 8 e to the negative 2x plus 8x e to the negative 2x. we can again pull out a constant of a common factor of e to the negative 2x, and we'll get negative 4 minus 8 plus 8x, which becomes 8x minus 12 times e to the negative 2x. Our stationary point is at x equals 1, and we're trying to find its nature. So we'll sub in x equals 1 for the second derivative to find its nature. Equals 8 times 1 minus 12 e to the negative 2 times 1 becomes negative 4 times e to the negative 2, which is obviously a negative number, but you can always write down that's negative 0.541. Say less than 0. Since it's less than 0, therefore at a local maximum, and therefore maximum at x equals 1. Right, so that's your part D done. Questions in the comments. Lastly, is our excellent level question, part E. A curve is defined by the equation y equals 2x squared minus y minus 2x ln x all over x, where x is greater than 0. The curve has a point of inflection at P, so second derivative d squared y by dx squared is equal to 0. Find the equation of the tangent to the curve at the point P. Equation of the tangent to the curve. Right. So obviously we're trying to find d squared y by dx squared. We have y equals 2x squared minus y minus 2x ln x over x. Since x is not 0, we can simplify this down to 2x minus 1 over x minus 2 ln x. Just divide every term by x to simplify our function down. So we get dy by dx would equal 2 plus 1 over x squared minus 2 over x. This is 1 over x, but if we differentiate that becomes negative 1 over x squared, which cancel out with a negative here, becoming positive. And ln x differentiates to 1 over x, and multiplied by the coefficient 2, becomes 2 over x. Alright? Now, we're going to get our second derivative, d squared y by dx squared. That is, 2 goes away, that becomes negative 2 over x cubed plus 2 over x squared. The negative 2 drops down, is our power rule, and this becomes negative 3. So negative 2 becomes negative 3. Same thing here, but it's 1 power less. Coefficient keeps at the top. Negative 1 over x differentiates to positive 1 over x squared. So that's our second derivative. And we're going to set that to 0 for point of inflection. So we get negative 2 over x cubed plus 2 over x squared equals 0. So 2 over x squared equals 2 over x cubed. Cross multiplying, 2x cubed equals 2x squared. Bringing all the x terms onto one side, 2x cubed minus 2x squared equals 0. Have a common factor of x squared, 2x squared actually. That becomes x minus 1 equals 0. So x equals 0 or 1. But if we look at the top, x is greater than 0. So x doesn't equal 0, x equals 1. That's our point of inflection at x equals 1. But then we have to sub it back in for y to find the point, the coordinate. Y equals 2x squared minus 1 minus 2x ln x over x. Sub 1 in, we get y equals 2 minus 1 minus ln of 1 is 0, so that becomes 0, and that becomes 1. That becomes 2 minus 1. 1 over 1 is 1. So P has coordinates 1, 1. That's the coordinate of the point of inflection. Now, we're trying to find the equation of the tangent. So, to find the equation of a tangent line, we will use y minus y1 equals mx minus x1. So, we'll have to first find the m first. M is the slope at x equals 1, which is the point of inflection. We know that dy by dx, which is our slope, equals 2 plus 1 over x squared minus 2 over x. So we can sub in x equals 1 into it. So our dy by dx will become 2 plus 1 over 1 minus 2 over 1. That becomes 1. Right, 2 and negative 2 cancels out. Get 1 over 1, which is 1. That's our slope. So you could say m equals 1. So now we can sub all our values 1, x, y, and m into our equation up here. Alright, we get y minus 1 is equal to 1 times x minus 1. We get y minus 1 equals x minus 1, y equals x, which is the equation of the tangent. Alright, that's your full equation done. Next part will be part 2. There will be another video. For the rest of this video, I'll be do a quick run through of where all the marks are. For all calculus papers up to at least last year, 2025, parts A, B are achieved level questions. C, D are merit level questions. And part E is always your excellence level question. Now I'll show you where each of the marks are. So, for achieved level question, you just need a unsimplified version of this. So this or equivalent. You could have just stopped here, and that would have been your first achieved mark or your U mark. Right. Again, part B is also achieved level question. You just need to get dy dx equals 2. That will be also your achieved mark or your U mark. That's 2 achieved already. Part C is your mirror question. For evidence of reaching stage 1, which is forming this inequality, that's stage 1. And that will give you achieved. You could set this as less than or equal to, does not matter. And to get your merit mark, you gotta find the correct inequality for acquiring values of x for decreasing functions with evidence of derivative. Right, so you need evidence of derivative, and you need inequality. You also need to find obviously the range of x for decreasing value. So up to here would have given you the merit mark or your R mark. Part D, also a merit level question. Achieved mark comes from correctly expressing dy by dx, which is this right here, or equivalent. So that would be your U mark. And mirror mark, you need to find x equals 1, so here, and you need to justify that it's a maximum using calculus methods and with evidence of derivative. So you gotta derive your second derivative correctly and say it's a maximum with all working. That is, at this point, will be your mirror mark, R mark, right here. Second derivative, you need to sub it in, and yeah, justification is also part of your mirror mark. Lastly, your excellence question. To get achieved, you need to correctly express dy by dx, which is 2 plus this line, 2 plus 1 over x squared minus 2 over x, or in answers is 2 plus x to the negative 2 minus 2 over x. That's your u mark. For mirror, you need to find x equals 1 with correct first and second derivative. So you need this for part of your R mark, and you need to find x equals 1, i.e. also rejecting x doesn't equal to 0. Up to here would have given you a mirror mark. And lastly, for your E7 mark, you need consistent equation of tangent from incorrect P. So you either mess up P but still work your way through. That would have been your T1, or correct solution but with one minor error somewhere. I don't know how you could do that, but sure, probably might mess up here. But that's where you get your E7. To get E8, you need correct equation of tangent found. So that gives you your E8, which is your T2. T1, T2, you need both T marks to get E8. One T mark to get E7, which is when you either mess up P or have a minor error but correct solution. This is the solution. Alright. Okay, hope this video helps. And lastly, to get achieved, to pass this question, you need at least 2 U marks. To get merit, you need at least 1 R mark, and to get excellence, you need at least 1 T mark. Yeah, that's the end of this video. Hope it helps, and thank you for watching.